Great. Thank you very much, Amy. Thank you, everyone, for tuning in today. We're excited to present this webinar to you and hope that you will find it beneficial. This is our next installment of the Dave and Jason Show. And so today's top tips and tricks for using Inventor, we're going to cover some drawing file tips and some part file tips. Jason and I have some shared tips within the sheet metal part files. And then I'll turn the time over to Jason after I'm done with mine, and he'll go over his assembly file tricks and tips and iLogic forms and sketching, and then his portion of the sheet metal part files. So that's our agenda for today. And with that, I'll go ahead and switch over to Inventor, and we'll get the demonstration started. All right, so the first thing that we're going to look at today is a drawing file. So in looking at drawings, I'm going to go ahead and open up this tank saddle weldment drawing. And the first trick that I'd like to show is about precision sections. So we all know that we can create section views within our drawings. We can use the section tool, we can select the view, and then we can place by drawing our line segments. We can create our section view. And when we do, once we get done drawing the section line, we go ahead and we place it. And that's easy. We all understand how to do that. The thing is that this section line can easily be moved by just clicking and dragging it. So an accidental move can happen as you're moving and clicking around. But in addition to that, if this view updates any, then updates to the view can actually cause the section to move around just slightly. So if we want to make sure that we have a precision section placement as well as keeping it from moving, we'll use these little tricks here in order to do so. So taking this section view, what we can do is right click on it, and we can click edit. When we do that, it puts us into sketch mode, and that section line that we have drawn can then be dimensioned using the dimension tools from the sketch tab, or we can even constrain it in order to place it. So if I decided to dimension, I can select one of my drawing entities, let's say that edge of that feature there, and I can place a dimension, say 5 inches, and then I can finish the sketch, and now that section is precisely placed. And you can see I can't drag it. It actually, when I try to click and drag it, it shows that there's a dimension tied to it. So it keeps me from accidentally moving that. Also creates the precision so that I know exactly where that section is. And so there'll be times when those needs are there where you don't want that section of view to accidentally be moved. So again, just selecting the section view, editing it, and then again we can either take that dimension out and then it's free to move. We could use also a constraint. So if I wanted to constrain it, like maybe with a collinear constraint, and select that object, now my section line is collinear to that line, and then I could click finish sketch, and that's where it does its section view looking the other way. So that's my first tip, is precision section lines, the ability to lock a section line in place and keep it from moving. All right, so the next thing we're going to look at, the next tip, is going to be selection priority. And specifically when we're looking at a drawing, we may want to make changes to multiple dimensions at one time. So you can see here that I've got multiple dimensions in my drawing. I may want to make some sort of edit to those. Traditional method for doing that would be to select each dimension and then use the control click on the keyboard and go through and select each dimension that I want to make a change to. That can be undesirable for a large drawing with lots of dimensions. So what we can do is use this tip here. In the selection priority drop down, select all model dimensions, no, not all model dimensions, select all Inventor dimensions. So when I do that, it's going to select all of the dimensions that are in all of the views of the drawing. And then from that, I can make changes. I can go over to the Annotate tab and I can select which standard they're going to use. So I can switch to the standard, and you can see they all make the appropriate changes based on that one selection. So that would be my next tip there, is just to be able to change your selection priorities, and specifically within drawings, to be able to select all your Inventor dimensions and be able to take care of changes that you want to make to those dimensions all in one fell swoop. So that's my second tip. All right, my third tip is what we call an apparent intersection dimension. So in looking at this saddle some more, I'm going to go ahead and get rid of this section view real quick. Delete that out of the way. I have the ability with this kind of odd shaped endpoint here. It's pretty easy to just throw a dimension for an overall height by grabbing that edge there and maybe grabbing this edge here, and I can get an overall height. But there will be times where I want to actually dimension to the apparent intersection of two faces or edges. So what we can do is use the dimension tool, and I'll grab this bottom edge here, and then what I will do is I will click on intersection and select this line here and this line here. Oh, that didn't work. Let me try that again. I think I need to grab here, and then I need to grab this line here, and then right click and select intersection, and then grab that line. So you can see here when I do that, then that gives me that ability to grab the apparent intersection of where those two lines or edges meet, and then I can come out and I can place it. Once I place the dimension, Inventor automatically places two extension lines off of those two edges, giving me that apparent intersection. So I'll show that one again. This time I'm going to do two apparent intersections. So in this case here, I want to find out what the distance is from the apparent intersection of these two edges to these two over here. So in the dimension tool, select, right click, intersection, then I pick that line. Then I'm going to come over here and I'm going to select this line. You can see it's giving me the apparent intersection of the first two selections, but again, Inventor always wants to give me a preview based on my selection. I'm going to not accept that. I'm going to right mouse click and select intersection again, and now I can pick that edge there, and it will give me the apparent intersection. And then I can place that, and I have the apparent intersection of both segments. So that's my third tip. So that's it for the drawing views tips. Again, just kind of a quick recap. Precision section views, being able to dimension or constrain our section views to entities within within the sketch view. Also the selection priority, to be able to select dimensions from the selection priority and be able to then make modifications globally to all dimensions in the drawing. And then the third one is the apparent intersection. Okay, so let's take a look at another drawing here. And I don't know what happened to that other file that I had. Oh, I know where it's going to be up here. There it is. Okay, so looking at this other part here, going to give you some tips from within the part modeling environment. First thing I want to look at is the EOP marker. The EOP marker, there's some really cool tips that you can use to help you with your part modeling with the EOP marker. The first one that everybody probably knows about is that you can move the EOP marker up and down, and we kind of use this to examine our parts and see how things are built. So the EOP marker can be moved up and down relatively easily, and everybody kind of knows that, I think. The cool thing is to be able to just right click and say, let's move the EOP to the top. Okay, and then once we do that, what's really cool about this is then I can go ahead and right click on the EOP again, and I can delete all features below the EOP. So that's a really cool function there, is the ability to be able to do that, to delete all the features below the EOP. All right, so let's just go ahead and do that. So what I'm going to do now is go ahead and create a part here. And I'm just going to do a 2-point center rectangle. And then go ahead and extrude that. And I'll go ahead and put another sketch on here. And this time I'll do a rectangle, a regular 2-point rectangle. And I'll go ahead and utilize the existing edges of the model just by scrubbing them. So when I click this rectangle here and I go to draw it, notice that it automatically projects the geometry of the existing edge. So I don't have to manually do it. Inventor automatically pick that up. So I'm going to click that, and I'm going to turn that into construction. And then I'll go ahead and I'll do a project geometry, and I'll select that edge, and we'll make it construction as well. And now I'll go ahead and place a dimension. For each side here. And let's make it 4.5. All right. And now I'll go ahead and extrude that with a cut. I've forgotten all about this model here. Okay, so here's what we're going to do. We're going to change that. All right, let's delete that extrusion there. We're going to do a shell. That's what we're supposed to do here. We want to do a shell, and that's going to bring me up to my next tip, which is going to be the unique wall thickness. So within the shell command, if I click shell, I'm going to get a preview of the thin wall shell feature that we're going to create. And the first thing we always do is we're going to remove faces. So I'll select this face to remove, this face, and this face. And I'll change my thickness to 0.25. Yeah, let's go 0.5. Okay, so I changed my thickness to 0.25. One of the things I have the ability to do is use this little chevron down here and click, and I can add a unique face thickness. So I click here to add, and I select this bottom face, and I'm going to give it a unique thickness of 0.75. So you can see there that I have that ability. This is another cool trick, is to be able to set a unique wall thickness within the shell command. So let's make that 1 and then click OK. All right, so the next thing I want to do is I want to go ahead and place a fillet on these two corners here, and I'll go ahead and drag them up, and we'll make them 1-inch radius. And I'll click OK to that. The next thing I'm going to do is I'm going to go ahead and place a sketch on this face, and I'm going to draw an open profile and show you another very cool trick for Inventor here. So I'm going to do a 2D sketch. I'll go ahead and place the sketch on this face, and now I'm just going to draw an open profile. Just going to draw a line here and a line here. And I don't have to place any dimensions on them if I don't want to. Again, it's just an open profile, which kind of violates our understanding of how to create an extrusion. In order to do so, it needs to be a closed profile. I'll show you how we don't need to do that. So we'll click Finish Sketch, and then I'm going to click Extrude. Now, what I'm going to do is come down here and select that open sketch. When I do that, I get this crazy extended 2 different profiles. So basically what Inventor's doing is kind of like the rib tool technology, where it's taking those 2 lines and it's extending all the way out to the boundaries of the model and giving me a closed profile to the boundary. And then because of those lines, there's another closed boundary that goes out to the bounds of the model. So it's creating two bounds there. I have the ability now to pick inside or outside of those closed boundaries that Inventor is projecting to the edges for me. So I'm going to go ahead and click inside, and when I do, I can drag this arrow up, and as I do, you can see that what's happening is Inventor is obeying one of its criteria within the dialog box for extrude command, and it's this little button right here, match shape. So match shape is on by default, and what happens is as you use this tool, because it's extending those 2 lines to the edge, it's now going to match the existing shape as I extrude up. So very, very cool tool to be able to utilize. Now, if I said, let's not match the shape, I can still extrude, but those lines only project to the edges or the end of the existing sketch. So, or the existing plane. So I can't go any further than where I'm going, and the shape doesn't match. So I can, it's something I can uncheck, or I can check. And of course, I can add my taper angle to it and make my component taper. And of course, that's all going to depend on my length of my extrude. You can see the preview disappears. So as the taper angle is too large, that's going to disappear. So we can go something smaller. So that's how that works. So I've got the ability to do that extrude, place the taper, but match shape is the important thing. And the criteria is, what's really cool about this is that it's an open profile. We just violated our basic understanding and rules of Inventor. I have an open profile and I'm allowing it to project to the bounding edges of the model. All right, so the last thing I'll show you here in this part model is the hole command. So I'm going to place a sketch here with a point, and it doesn't matter which method you use, whether you're going to use a point or you're going to use a linear hole or what it is. So the point is not to what type of specific hole you're using. The next tip I'm going to show you is a new tool in Inventor that allows you to fix a known problem. So here I'm just going to expand this hole out so that it's bigger, and it's through all's determination. So I mean, all the things here are normal in the dialog box, but what you notice is that it violates this curve, and so the hole is not generated through this curve. So once our hole starts to penetrate into that curve, then it can no longer create the hole. So we would normally have to come back and maybe do a work plane above and above this arced curve, this fillet here, so that we can cut all the way through that, or we might cut through the bottom in order to create it. Well, now we don't have to do that. Now we can come over here and we can just click on this nice little checkbox here, extend the start. So when we extend the start of the hole, it now goes up and catches everything. So nice little new tool there within Inventor, within the hole command. All right, I think those are some cool tools. I got a couple more to show you, and then we'll turn it over to Jason. So let me go ahead and open up a sheet metal part. So this clip here, I want to go ahead and be able to maybe reduce the weight a little bit, or maybe to be able to create some slots so maybe moisture doesn't accumulate under the clip. For whatever the reasons, I want to go ahead and I want to place a slot in the clip. And what I want to do is I want that slot to start on this face and I want it to end on this face over here. So what I'm going to do is I'm going to start my sketch on this face. So I just click Start 2D Sketch and select that face. And now what I want to do is I want to be able to draw my slot, but I need to maybe know how and where it fits relative to this other face here. So what I want to do is I want to come up to our project geometry and I'm going to click the drop down and I'm going to project flat pattern. So this is a very cool little tip here to be able to project the other edge into the flat pattern onto your current sketch. So I click that and I'm able to see the flat pattern of on my current sketch. So now I can come in and we'll do a look at here. I'll do a look directly at that sketch, and now I can use, say, my slot tool, and maybe I want to put that directly on that mid plane. And let's go, how big do I want to go? So 0.375, and then I'll go 0.25 for my slot. And I'll finish the sketch. So that's my first tip within the sheet metal environment here, is to be able to project the flat pattern onto an existing sketch, and that way I can utilize the geometry, or at least get an idea of how that's going to play out in my sheet metal. So I go ahead and do that, and then I come over here for my last tip. I'm going to click this cut tool, and I'm going to select that slot that I created, and I'm going to go ahead and create a cut. Now, when I normally do this and I click OK, it only creates that cut on that face that I had the sketch on. So what I need to do is I need to, in the cut dialog box, I need to check this box here, cut across bend. And when I do that, you get a preview, and you can see that it's just going to follow the bend of the sheet metal and go ahead and create that cut across. All right, so that's my last tip there, was the ability to cut across the bend. I think those are some pretty good tips. If you haven't seen those before, then try them out. If you have, keep using them and keep finding other ones. And so right now I'll turn it over to Jason, and he'll show you some of his tips and some more on the sheet metal side.
All right. Thanks, Dave.
No problem.
All right. And just verify for me, Dave. Can you see my screen?
Yep. Yeah, it just flipped over. We can see it great.
All right. So the first thing that I'm going to start out with is we're going to start out in our part environment, and we're going to be talking about some sketching tips. And the first key thing that I want to point out is talking in regards to the trim and extend tool. So you'll notice that for the users that have been using Inventor, that when we start the trim command, notice that we can go through and select different segments to trim. But one thing is, especially if you have a pretty intricate sketch where that could be a lot of clicking, right, to finally get to the portion that you would want to stop or trim that line to. So with the trim command active, if I hold down, let's say, Control, and I want to trim this vertical line here all the way to this horizontal line. So I can hold down Control, select that line, then I can right click and choose Continue, and notice that I can trim that entire segment all the way down to this particular sketch entity here. Also, what I'd like to show is being able to toggle quickly between the trim and extend command. So for instance, let's say that I trimmed this line here by accident. Or maybe once I trimmed it, I come to realize that, you know what, I really need that line to be where it was at. So instead of coming back up here and toggling on extend, you have the capability, if you hold down Shift while in the trim command, it toggles to the extend command. And once I release Shift, I am back in the trim command once again. And that works vice versa. If I'm in the extend command, holding down Shift, it'll toggle to the trim command. Another thing that we have the capability of doing is, you might not be able to see it, but I'm going to drag it around just a little bit. So I'm holding down the left mouse button, and what it's actually doing is giving me a trail. And by holding down the left mouse button, this is known as dynamic trim. And like I said, this would work the same for extend as well. But if I hold down the left mouse button and just start dragging that trail, anything that this touches is going to trim it, like so. Okay. So we got being able to trim to specific entities, and that also works for extend. If you want to, like for instance, if I'm wanting to extend this line all the way to this line with one fell swoop, I can hold down my control key, select that line, let off of control, and notice whenever I'm hover over this line, it is extending all the way towards that first entity that I selected. One nice other tool that you might not be aware of is, for instance, utilizing the line command. Not only can it be used to create lines, but it can also be used to create tangent arcs. So the way that this works, you'll notice that I'm still in my line command. Well, the trick is if you go back to an endpoint and you left click and hold it and just drag it in the direction that you want to create that arc. Okay, and you can continue creating arcs with this. So just return back towards the endpoint and notice I'm just continuing creating these arcs like so. So it's just a nice little trick here. It just cuts out of having to switch between commands. So for this particular one here, let's say if I was going to utilize the line command to create a tangent arc, let's say for instance, I'm going to go ahead and extend this line over to that segment. Start my line command. Maybe I wanted a slot, maybe something in here like so. And then using my dynamic trim, just come in and drag and remove the entities that I'm not wanting, like so. Okay, so for the sketching environment here within a part, that shows my tips for utilizing the line command and creating tangent arcs, and then also how you can use the trim and extend functions to trim to or extend to a specific sketch entity, and also how the dynamic and for the trim and extend work as well. So let's switch over to our sheet metal environment. And what I'm going to end up doing is I'm going to offset a work plane here. I'm going to create a sketch on it. Okay. And we're going to utilize maybe a tool that you didn't know had the capabilities of doing this, but we're going to create some faces with bend options on between two parallel faces. All right, so the first trick here is, remember I said I wanted to create an offset work plane. So normally, we would come in here and use our work feature here to create an offset from plane, but we can actually create that while we are creating a 2D sketch. So with the 2D sketch activated, I'm going to select and hold this face, and notice it's giving me the ability to offset. So I'm going to offset that, let's say 3 inches. And once I accept this, you'll notice that it has already gone into my sketch environment. Okay. So we're going to go in and I'm going to place a shape in here, and we'll give it some dimensions here. So maybe I want it to be, let's go ahead and make that a little bit larger. So let's say 4 by 2. There we go. And then I'm just going to line this up just a little bit here. So I'm going to use some of my geometric constraints. I'm just going to make it where this will stay in the center of my base feature that I have. Now let's just go ahead and make sure that we have this fully constrained. All right. So once I have this, I'm going to utilize the face command. So you'll notice it has already selected that face that I just created. But the nice thing is here is I'm going to actually make this to where I'm going to connect this new face to this base feature that I have down here at the bottom. So I'm going to select the top edge, and you'll notice once I selected that edge that it has given me some bend options here. So currently this is my fixed edge, and you'll see the preview there. My 45 degree. Now you'll notice that to hold that 45, notice that it's actually taking away material from that sketch that I created so it can hold that 45-degree angle. And during your design process, maybe you actually want this face up here at the top to hold that 4 inches, so we have a total area of 4 with the material. So we can also toggle the direction here. So this is called flipped fixed edge. And once I do that, notice what happened here. It's not removing the material here on this face, but it's actually removing material from my base feature. And just so you can see a preview of what this looks like or the final results, I'm gonna go ahead and accept that. And depending on what your sheet metal rules or your sheet metal defaults are set to, notice it's already given me my bend reliefs based off of my sheet metal defaults. And then I want to show you another option that we have here is we have full radius. Notice how that would switch to the other outside edge of that face. If I accept that, notice it's adding material once again. And then we also have just a 90 degree. Okay, like so. Okay, so you notice that we created a sketch on this face, and while at the same time we did an offset work plane. Found out that the face tool can do some other cool things as well in regards to controlling bends and adding and taking away material. And another thing that I want to show is let's talk about some of the things that we can do in regards to our material browser. Just show you a quick way that we can actually add material to a new library just on the fly. Okay. So let's say, for instance, that we might need to switch my project real quick, but we'll see if we can create this just real quickly. All right. So I'll just call this Jason and we'll save it here. Okay, and let's say, for instance, that I'm wanting to make a copy of this aluminum. All right, so notice that I have it in my document here. So with this, let's say we're going to create a new, let's say a company standard material. So I'm going to just duplicate this one, and I'm going to rename this. So let's just call this, let's just call it Jason's Aluminum. Like so. Now, currently, right now, the first thing that I'm going to do with this particular one is I'm going to go in and I'm going to edit. And I know for this one, let's say, for example, I want to change what the appearance looks like. Okay, so I'm going to, we could make modifications here if we wanted to. You know, I could change the finish. Maybe I want it to be polished, like so. The type, I am going to leave it in aluminum. So let's say that I'm happy with this here. All right, so the quick tip here is once you create that material and have added your appearance, is how quickly you can grab and add this material to your library. And it's as simple as just dragging and dropping that material to your library, like so. Okay, so that's the last tidbit in regards to the materials, just creating the material, dragging it and dropping it. Now, if you had categories set up within your library, such as this, then what you would end up doing is, for instance, if I had, let's say, a metal subcategory in this folder, then you would just drag and drop that into that category, and that's where it would get assigned to. So currently right now, I just dropped it into my top level. So that's why it's saying uncategorized. Okay. Now the next thing I want to do is I want to jump into a part, and you'll notice here I've got a coffee cup, and I want to point out that within this particular model, I have actually got specific parameters that I have renamed. So I want to show you how quick and easy it is to create what is known as an iLogic form. Okay, so in the Manage tab here in the iLogic panel, I expand that panel, you'll notice I can select Add Form. And I'm going to create this form where it's tied specifically to just this document. So we'll call it, let's say, Coffee Configurator, possibly. You can name it anything you want to. And you'll notice here, I'll have a preview of my form over here to the right. And with my parameters that I have renamed, they show here towards the left, and I want to actually add these parameters to this form. And it's as easy as dragging and dropping those onto my form. And notice how it's starting to populate. So I'm just dragging those over, saying those are the key ones that I want to add and be able to control in this form. And then I'm not going to go into detail about this, but you have other options that you can do as well. We can add groups, tab groups. You could even add a picture to this form if you wanted to. And you'll notice there's also some things here that we can modify. So for instance, you see where, since we know that we can't name parameters with spaces, you notice I used an underscore. So here I can modify what is known as the labels here, because it's still going to reference the original inventor named parameter. So for instance, if I just want to take out the underscore and have a space instead, just so it shows up maybe a little bit cleaner on my form, I can do that as well. So the nice thing about this is once I accept everything that I have, is if I go in and to my iLogic browser and look at my Forms tab, there's my Coffee Configurator form I just created. Now I can just come in just real quickly and make some modifications. Okay. So you notice how, it's kind of neat that you can create these forms. If somebody's aware of these, and they come in and make modifications real quick, they can. So that's my next tip that I was going to share with you. Now, the last thing that we're going to talk about is some tips within the assembly environment. And you notice here I've got an arbor press, and the first thing that I want to share with you is about adding parts. Okay, so you're aware that if I wanted to place some more components in here, we can always go to our place component over here in our component panel, and we can, place in as many instances as we want of particular parts. But another thing that we have the capability of doing is in our model browser, you have the option, let's say for instance, I needed another face plate in this assembly. So instead of going up to place, I can actually go over here to my assembly browser and select this part and hold it, and I'm going to drag it over here to my graphics window. So I can just add as many parts as I need to just by dragging and dropping. In addition to that, most of you possibly use dual monitors, and what I want to show here is it works pretty much the same way from your Windows Explorer. So for instance, here in my Windows Explorer, I'm going to drag, let's say, this hex bolt that I have, and I'm just going to drag it over here to my graphics window within Inventor. Okay, and you also have the option, let's say for instance, I wanted all of these here. You can select all those and drag all of those over, and you'll notice it has placed an instance of those as well. Okay, so that's placing components. The next thing that I want to share with you is a nice quick little trick about constraining. So we know we have constraints up here at the top that consist of different types, mates, angles, tangents, inserts, and symmetry. And you, of course, if you're aware of these constraints, most of these have different solutions as well. Well, the nice little tip here is, let's say for instance, I want to constrain this bolt to this hole. Now, if I hover over this face, and I'm going to select Alt, and then I'm going to click and drag this face, notice there at my mouse pointer that I have the insert symbol there. Okay. Now, we also, let's say for instance, I didn't want that insert constraint. Maybe I want it to be a mate constraint. Well, the nice thing is I can hit the letter M on my keyboard. So for instance, let's hold down Alt. I'm going to grab that face again. All right, so now since I chose a flat face, it is showing my mate constraint. If I click I, that goes to my insert constraint. And the way that some of these work here, so M on your keyboard is for mate, A is for an angle constraint, T is for a tangent constraint, like I said, I insert constraint, and then also you have some other options like R for rotation motion constraint, S for a translation or slide constraint. So those are examples of how you can toggle between those. Now remember I said that we have different solutions as well. Okay. So I'm going to change this to an insert constraint, and then when I come over here and hover over this, right now it's giving me the intended solution that I would want. But notice if I want to toggle between solutions, if I hit the space bar, that's how I can toggle between those. Okay. All right. So that's the nice little shortcut of constraining using the Alt key. And then lastly, what we want to just show real quickly, and if you were not aware of this, let's say, for instance, we can have some large assemblies, right? And then you'll notice how our browser can get pretty long. So we can go in and kind of clean this up a little bit. And for example, what I'm talking about is being able to add assembly folders. So I'm going to come up here to my top level assembly, right click on it, and choose create new folder. And usually I'll use something like this to maybe create a folder for like hardware. And then we'll notice all of these nuts and bolts that I have. I can select all of those and just drag those into that folder. And you'll notice that everything is located inside here. And another thing that I like about this is being able to control like the visibility, or if I wanted to suppress all that, I can do that at this folder level. So it's kind of nice being able to create these folders. So that is one thing that I wanted to point out. And then one more thing, and then I'll turn it back over to Amy, is if you guys have, or ladies, have ever noticed that if you've hit the Alt key by accident, you'll notice all of these numbers and letters showing up here at the top in our ribbon and also in our quick access toolbar. Well, what that's actually doing is actually showing you the keyboard shortcuts. So for instance, if I wanted to go into the Assemble tab, I could hit A, and then notice here that it gives me even more of those shortcuts, right? So if I type in ET, notice that will launch my parameters. So for those that are fond of keyboard shortcuts, just remember the Alt key, that's what it's showing you up there at the top. Okay. So I hope you enjoyed what you saw today from Dave and myself. And right now I'm going to turn it over to Amy, and she'll conclude this webinar.